Hello. So um, today's task is 1382 balance a binary search tree. I saw it before. It was like 3 years ago. So let me quickly read the question and I'll start um, solving it. Let me also check the audio. I guess, yeah, that's fine. So, to balance binary search tree, how I can balance it possibly? So the idea should be the depth should be the same for all nodes or like all leaves or like different by one. So here the leaf 4 has like depth 1, leaf 2 has depth 2. In this case, they both have like depth 1. So the input for this task is root, and I need to basically to figure out how I can rebalance it. That's pretty interesting question. I guess it's related to AVL trees. Oh, definitely. We'll start from the middle, like, but how I can find the middle here? And um we have 10 to the power of 5, 10 to the power of 4 nodes. What I'm thinking about right now is like, can I just go through the binary search tree? It's already binary search tree, so I wonder like what's gonna be better, either building it from scratch or um or like moving the branches or like moving the nodes. Let me, I actually, to be honest, I don't know how to do that. Let's search, I don't remember. AVL trees. So how I can AVL tree? So we have, I can build it based on the, save the elements in array, and then it sounds like a very difficult problem. If I do in order traversal and save the elements in the array, and then I can like and then I can like split half, second half. I understand zero here. Why, when we need to do right rotation, when we need to do left rotation. It's very interesting with three nodes. So what I wanna do, I wanted to do that in, I wanted to do that in a kind of constant space um, complexity. And it seems like constant space complexity is pretty complicated here. I should somehow still In order to fix this, I need to have a size of the subtree. In order to calculate the size of the subtree, I still need to go maybe to save it somewhere. Yeah, I need to save it somewhere. If it was the size here, say the size of the subtree, it might be better. But yeah. Okay, so my plan is to do first save the do in order DFS, then do save values into array, and then do the array traversal with the divide and conquer plus create a new tree. So and I'll have a array list. Let's say we have integer accumulator. And let's say I want to do this in order DFS. Order DFS. And I want to do if node equal now, just return if node dot left not equal now, I'll do in order DFS node dot left, and then accumulator, then accumulator add node dot val, and do if node right not equal now, I'll do in order DFS node dot right and accumulator. Here I'm gonna void so I'll call in order DFS root, then okay. So parent gonna be null, left bound gonna be accumulate 0, right bound gonna be accumulator that size -1 and then accumulator, and that's gonna be return. It's gonna return the tree node, the root tree node. So private tree node parent. You probably don't need even have like parent. So we have int left, int right, and then array list integer accumulator, and then if left equals right, then I'm gonna create new return, new tree node accumulator dot get. Get left, and then else if we don't have this one, int middle equal right left plus right minus left over 2, and then if left greater than middle, less than middle, I'm gonna do this tree node. So if I'm gonna create a new tree node equal node new tree node, and then the value gonna be accumulator dot get, and then m at index m, and then if left is less than m, then node dot left equal divide and conquer left, and then m minus 1, and then accumulator, and then if m less than right, then node dot right equal divide and conquer m plus 1, and then right accumulator, and then I'm gonna return node. Something like this. Okay, let me run this one. Integer array list. What if I'm gonna reuse three nodes? Yeah, but I still don't like this approach. Um, I would, I would, I would love to have kind of size reference and so they have a size and they save it within the node. Yeah, it's interesting why Leetcode doesn't have this kind of in place balance binary, let's say binary search tree in place, and if you have like this ability to save the metadata, you can save it. Okay, rotate right away, we call it. Move right left. Oh, this one is great. So balance node. Uh-huh. Can I derive this? Let's say um, something like that. Public static. Let's say private static class tree node meta and meta. And let's say I have the int value, and then I have tree node left, and have tree node right, and then yeah, let's say meta this one, and then I'll have, let's say, public, 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 and then let's say I have public object meta, and let's say we're gonna have private static class red rb3 meta, where it's gonna have size, color, and the color is true or false, red or black. Is that right? Yes. Boolean color. So you have this one and then Boolean color. And then what I wanna really do here is to somehow when I'm gonna create this class um, three three node meta equals of new three node meta, and then I wanna put dot meta. Let's just call it node and meta equals new three node rb3. New rb3 meta, and then let's say size 0, color true, or like size 1. Can I run this? rb3 meta 3 node and meta. Let's say 3 node meta and 3 node, how to say, with meta. Doesn't mean it's with like some kind of social network. Um, um, yes. Can I convert it to object? Object conversion. Hmm. Do I really need that one? Hmm. Yeah, I can do that. So imagine they had this meta object, and you can assign any kind of meta information there. So it will make this task a little bit, I would say, interesting, because you can really solve this task with like with better like memory if you take into account that kind of meta already allocated to the tree node, but it's like dummy. It will make this task really interesting because I can apply either AVL3 algorithm or like red black tree algorithm. Okay, that's it. I'm gonna wrap up. Um, um, so short summary. I spent some time like conceptualizing the solution. I thought that maybe I can do that in place, like rebalancing the tree without like saving nodes into the separate or like nodes or like node values into separate integer array or like three node array. So, and actually, I guess I thought within like 20 minutes, something like that, even like with thinking about this problem and like not looking to the previous solution. Also, let me check what I have for the previous solution here. Permissions. Um, um, yeah, pretty much it. The same kind of algorithm. Yeah, so I consider this pass, but if the task would be a little bit more complicated, I would probably fail it because like if there were like meta information and object and like red black tree or like AVL trees will be allowed in the solution. In otherwise now I have to recreate like three nodes, save meta information is in these three nodes, and then convert it back. So it's much gonna be memory impact gonna be like huge. Um, but if they were like at least like size or meta information, that would make the job easier. Yeah, that's updates from my side. Consider this pass.